When you connected those dots, did that change your worldview in any way when you discovered that the bedrock of the laws of nature, it's random, it's stochastic, it's probabilistic?
Oh, yeah.
What was that feeling like to come to terms with the fact that bedrock, the foundations are all random?
Well, just say that. Just think how powerful this is. Look, and maybe, I don't know how much we're going to talk about Jacques Monod and some of my adventures in Jacques Monod land, but it's up with you. Okay. But, okay, we'll have to talk about who Jacques Monod is here in a second. But so Monod is one of the co-founders of molecular biology. Let's get this clear, with an incredibly interesting backstory that I had the pleasure to explore as an author. Hold your questions if you want to go there for a second. But because Monod lived a very rich and interesting life in and out of science. But in science, and maybe it's the French thing, maybe that's the way he was brought up. He thought that science was, a lot of people think about the purpose of science as technology, the stuff that comes out of science and engineering. When he thought science really, its fundamental purpose was to sort of examine our place in the universe. Yeah. And Monod's, who had, a key role and a front row seat to the revolution in genetics and molecular biology in the 40s, 50s, and 60s. He was motivated to write this book, Chance and Necessity, because he had that dawning realization that, oh my goodness. I mean, he would have said, and he essentially said in 1969 or 70, it's game over, right? That all these views are untenable in the light of the fact that clearly the source of all diversity in the biosphere is random. And that takes away a lot of agency that others had seen. 50 years later, let's expand that out. The reason I wrote a book called A Series of Fortunate Events is I felt that, and I couldn't admire Monod more, I thought we could say even more 50 years later. Can I take a shot?
Yeah.
All right. I'll give you one thing about saying more. Okay. Different scale. But everyone's heard of the asteroid that hit the Earth and wiped out the dinosaurs, right? But it's a spectacular discovery. Just, fair to say, kind of, completely out of left field. So much so that it unnerved scientists for probably a decade or so. And there was some fierce resistance to it. So the discovery, the key paper was in 1980. So this is just a bit after Monod's time. But as we've now come to study, through all sorts of people have studied that event, and it's an incredible thing. Just to remind you, this 66 million years ago, this asteroid about 6 miles wide hit the Yucatan Peninsula and triggered a mass extinction. So to understand how that triggered a mass extinction and why something survived and what disappeared, this has all been fertile areas of work for 40 or more years. And I've had the pleasure to go to various parts of the world and put my finger on that boundary. So it's a fallout layer, essentially, across the world, where both in the oceans and on land, the debris that rained down across the Earth after that impact, because it blew about a 120-mile wide crater in Mexico, fell across the Earth. You can put your finger on that boundary in hundreds of places across the planet. And you realize on that boundary, which may be, a centimeter to maybe 3 or 4 centimeters wide, you realize the world below that boundary and the world above that boundary are entirely different. And you look in a rock face and it might be it's a layer cake. Boom, 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 boom. So you're standing, you might climb up a few hundred feet. So that hundreds of feet represents tens of millions of years. And you put your finger on that boundary. And something happened on the Earth, essentially that day, that changed everything. And for 150 million years prior, it was the world of reptiles, dominated by the dinosaurs and their kin in the ocean, the mosasaurs, all that kind of stuff. And after that, they're gone. And what emerges, pretty much in their place, are mammals and the ancestors of us. Okay. So why is this so profound? Because that asteroid could have easily missed us. And that asteroid could have easily hit somewhere else on the planet and not had as great effect as it did. And when you think that thing's going at 50,000 miles an hour and the Earth is turning at 1,000 miles an hour, okay? It easily could have not happened. And if it didn't happen that way, you and I aren't having this conversation. All right. The Celtics aren't headed to the playoffs. Lots of things are different. Okay. All right. So, I mean, just take that scale. And I think I like talking about that event because it puts the trajectory of life on Earth changed in an instant when it wouldn't necessarily had. I mean, 150 million years. That's a long time. Just chugging along. Lots of evolution happening, lots of things happening. But roughly 75% of species on the planet gone. You think how bad life was to take out 75% of the species, including tons of plants. I mean, think how hard it is to extinguish a plant completely extinct, right? So you got to cut off sunlight, all this kind of stuff. So conditions were really, really bad. Didn't have to happen. That chunk of rock could have easily missed Earth. It could have hit somewhere else on Earth. It turns out a lot of geologists think that where it hit in the Yucatan, just turns out that what was in those rocks, sulfates, carbonates, made a kind of a toxic stew in the atmosphere and played a role in the severity of the mass extinction event. So, that's chance at a cosmological scale, right? And people talk about Earth coalescing out of the planets, et cetera, et cetera. That's a long time ago. That's remote. I'm telling you that life that's fairly familiar to you now. There were birds in the sky, there were small mammals around, there were dinosaurs, and you've seen all them, and all there were butterflies and all sorts of creatures, and wham, okay, and it's a total reset of life on Earth. And what rises out of those ashes, mammals in that first million years become larger than they ever had in the previous 100 million years. And they diversify out into all those groups that you know today. So Jacques Monod couldn't tell that story. He could not tell that cosmological. So there's a collision that changed life on Earth, and it really is a collision. And when I say a random or a chance collision, you can pretty much say it was essentially so unlikely to essentially be random. That's one collision. I'll take another. This is a bridge version. I'll try to make it a more abridged version. But I want people to think about maybe 3 collisions. Okay. 3 collisions. Second collision is the collision of the Indian subcontinent with the Asian continent that built the Himalaya. That doesn't happen. We probably don't have the ice age we're in. And the ice age we're in, the last 2 million years, is a very peculiar time on Earth. I think the last ice age might have been 300 million years ago. You're like, well, okay, what about the ice age? Why does that matter? All this cycles of glaciers advancing and retreating and all that. Well, over in Africa, it wasn't so much about ice as it was about wet and dry cycles. And in the last 2 million years or so, during this ice age, there's a line of primates whose brains tripled in size. And that's us. Tool-using primates whose brains tripled in size. So I think it's a consensus view in anthropology and paleoanthropology that we are the kind of primate for all seasons, that we are the descendants of animals that found ways to cope with those cyclical changes in the Earth's climate. And we use tools, we commanded fire, we could get clothing, et cetera, et cetera. So we could, to some degree, insulate ourselves further and further from changes in our habitat. But that ice age doesn't happen without the collision of the Indian subcontinent. By the way, I didn't mention the Himalaya, about 40 million years ago. And that just has to do with the breakup of the continents that started over 100 million years ago. And the fact that Indian subcontinent, which was maybe 65 million years ago, down near Madagascar, raced northward and slammed into Asia and built that mountain range, which pulled a lot of CO2 out of the atmosphere and cooled off the world. And we entered the ice age. That's the second big collision. Third big collision is sperm and egg. And then we were into those numbers, that males can make an incredible number of sperm, an incredible number of genetic combinations, somewhere among 8 million different genetic combinations. So can mom. And that means that any two humans, for example, can make
8 million to 8 million.
Yeah.
Yeah.
70 trillion different kinds of babies. So that one sperm with that one egg, I mean, each one of us is truly genetically unique. There'll never be the same genetic combination again. All due to the random mutations in the sperm and the egg and that collision of just one sperm with that egg. So when I think about those three collisions, asteroids, continents, sperm and egg, yeah. So it wasn't just that deep genetic mechanism. It was saying the world is the way it is due to an incredible number of things that happened that didn't have to happen.